Okay, in preparation for your upcoming exam, we have given assignment 29. Now 29 is an assignment that will prepare you for each part of the exam. The first part of the exam, well, throughout the exam I should say, you will have to be able to name compounds as well as write their formulas. So I've tried to give you a pretty good review of naming and formula writing. I thought I'd go over it in detail with you at this point. So, number one from your review assignment, we have to name these compounds. Letter A, we have CD3PO4 in parentheses with a 2 on the outside. CD is a metal, cadmium. PO4 is a polyatomic ion. This is ionic. So to name ionic compounds, we first name the positive ion, cadmium. Now, some metals, remember, we need Roman numerals for. So let's take a look. Metals from group 1, we do not need Roman numerals for. They have a charge of, or oxidation number of +1 and only +1. Group 2, same thing, but +2 and only +2. Then aluminum has a charge of 3+, zinc and cadmium, that's the one we just mentioned, cadmium, are always 2+, silver is 1+. Now, all other metals, to the left of this pink line here, can have more than one oxidation state. So Roman numerals will be required in the name of a compound that contains those metals. Cadmium, however, does not need one. Now, PO4 is a polyatomic ion. So most polyatomic ions are going to end with ate or ite. So let's see what PO4 is. Right down here towards the bottom, PO4 3 negative is called phosphate. So we simply name the polyatomic ion. At this point we do not change the ending. So this is simply called cadmium phosphate. Now letter B, hopefully you can recognize as an acid. It's a ternary acid or oxyacid. It has hydrogen bonded to a polyatomic ion. To name these, we do not start with hydro. To name ternary or oxyacids, we look at the polyatomic ion and we change the ending. So NO2 is called nitrite. Ite ions, when they are being used as acids, become us or OUS acids. So instead of saying nitrite, we would say nitrous acid. And letter B is finished. Letter C, we have a nonmetal bonded to a nonmetal. So silicon is a semi-metal, but we're going to consider it a nonmetal. It's to the right of that line, and so is chlorine. When we name compounds that have nonmetals involved, we use prefixes to denote the number of each. So those prefixes are the Greek prefixes mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. The prefix mono is seldom used. So in this case we will just say silicon, and then for 4 we would say tetra, and as with all binary compounds we will end it with ide. So tetrachloride. Silicon tetrachloride, SiCl4. Letter D, Ba, parentheses around the OH with a 2. Ba is barium. Now, barium has a positive charge of 2 always. It does not need Roman numerals. OH is one of our polyatomic ions that does not end with ate or ite. OH is -1. It's called the hydroxide ion. So we just would simply say hydroxide. You'll notice we do not use prefixes when we name ionic compounds. We do not add prefixes like we did for SiCl4 in our previous example. Letter E, H2CrO4. Do you recognize that as an oxyacid? CrO4 is called chromate. Here we go. Right here. Chromate. CrO4 2 negative. Now, 8 polyatomics, when they're used as acids, become ic acids. So instead of saying chromate, we say chromic acid. And number 1 on our review assignment is completed. Now number 2, we're going to work backwards. This time, I'm going to give you the name, and you're going to come up with the formula. So for letter A, we have tin 4 fluoride. Tin symbol is SN, and its oxidation number is positive 4. That's what the Roman numeral tells me. It does not tell me the number of tins, it tells me its charge. Fluoride comes from fluorine, which is in group 17. Nonmetals in group 17 are -1. So, -1. Now, the sum of the charges has to be 0 when we bring these together. So I'm going to use 1 tin and 4 fluorine. So I'm going to put a subscript 4 next to the fluorine to denote that I have 4 of those. That gives me 4 negatives against the 4 positives. So the sum of the charge is 0. B, arsenic acid, or sometimes pronounced arsenic acid. This is an oxyacid. It does not start with hydro, so it must mean it comes from a polyatomic ion. Arsenic or arsenic comes from arsenate. So arsenate is ASO4 3 negative. So ASO4 3 negative, and hydrogen is acting like a metal with a positive 1 charge. So to bring these together so that the sum of their charge is 0, I need 3 H's. So H with a subscript 3, followed by ASO4. Only one of those are needed. Letter C, diantimony pentaoxide. Di means 2, so we have 2 antimonies. Penta means 5, so oxide is O and the subscript 5. So diantimony pentaoxide for letter C. Letter D, we have a binary acid. I know it's binary because it starts with the prefix hydro. So hydrogen acts as a metal with a 1+ charge, comes from iodine. So that's I, it's in group 17, -1. So we would have HI. Now binary acids exist when dissolved in water, so generally speaking we put the letters AQ in parentheses after the formula for a binary acid so the reader knows that it exists as being dissolved in water. And letter E for number 2, ruthenium 4 nitrate. Ruthenium is Ru. It has a charge of +4. That's what the Roman numeral tells me. Nitrate. Nitrate is right here on our polyatomic ion list. It's NO3 -1. So we would have Ru, and we need more than one of those polyatomics, so we put it in parentheses, and the number that we need on the outside. 4 negatives would balance out the 4 positives. Now, the rest of your assignment comes from your textbook, and we will do that as part 2 of this assignment on another video segment. So, when we do that, we'll begin with textbook page 886. Thanks.